Good morning, everybody, and welcome to our first day of geometry EOC testing. Before we get started, I just want to give you all a couple hints and tricks, good testing strategies that you should be using today. First thing I want to say is make sure you are reading throughout the entire question. Highlight those key math words that will help guide you on how to answer the question. Furthermore, make sure you're using your reference sheet as much as you can. If you're not sure of an answer, try to take your best educated guess as well. If you're stuck on a question for more than a couple minutes, bookmark it, come back to it at the end. Make sure you answer all the questions by the time the test is done. To get started with our content, the first things we're going to talk about is your complementary and supplementary angles. Complementary angles form a right angle as shown by the box, and those are two angles that add up to 90 degrees. Supplementary is angles that add up to 180 degrees, which makes a straight line. Another big topic is knowing about your vertical angles, because we see these all over in geometry. It's angles directly across from each other, and you got to know that those will always be congruent, which means they are equal measure. Furthermore, you should see some parallel lines cut by a transversal in your test today. The things you want to remember about these, in order for the angles to be congruent and supplementary, you need to first know that the two lines are parallel to each other. They could tell you with words, they could write that second arrow on there. And then we've showed you throughout this year how to label them with X's and O's in this pattern where you're kind of going around in a circle up at the top. That will tell you whether you have a congruent or supplementary equation. If both of your angles are by X's, set them equal. If they're both by O's, they're congruent, set them equal. If you get an angle by one X and one O, they're supplementary as well. Remember the names as well. They kind of tell you where they're at. Alternate means it's jumping across the transversal. Same side means it's on the same side. In between the lines is your interior. Outside is your exterior. Moving on, make sure you remember about your parallel and perpendicular slopes. Parallel slopes have the same slope. Perpendicular slopes, you want to flip your fraction and change the sign, and we can see that over there. You just flip the numerator and denominator, and if it's positive, make it negative, and vice versa. For questions like these, make sure you're writing out y equals mx plus b and plugging your numbers in. Go solve for b, and then write your final equation. Another big topic you should expect to see today is all about transformations. The big three are going to be your rigid motions, because you got to remember that a rigid motions is any way you can move a shape, and the size and structure of it does not change at all. So that'll be your translations, reflections, and rotations. Translations should be your easier ones. That's when you would just add or subtract from your coordinate points, and that's how they would tell you the rule. So subtract 2 from x, subtract 3 from y. For your reflections, this is when you flip your shape. If you reflect over the x-axis, you change the sign for your y. Y-axis, you change the sign for your x. If you are reflecting over the diagonal line, which equation is y equals x, you swap x and y. If you're reflecting over a diagonal line that's negative, shown by y equals negative x, you swap x and y, and then you also want to change both of those signs as well. For your rotations, you got to remember you're always supposed to go counterclockwise unless they tell you to. And then knowing the signs in each quadrant will help you out a lot, because if you go 180, you just change both signs. For 90 and 270, swap where x and y are at, figure out where you will land on the graph, and that will give you your signs. Moving on, kind of like your rigid motions are your non-rigid motions, which is going to be your dilations. Your dilations, the big idea here is that it's going to be the same shape. It's just going to be bigger or smaller. And we just multiply your coordinates by something called a scale factor as well. And then with transformations, remember, before you move your shape is your pre-image. After you move it, we just call it your image. Along with that, if you do want to find rotational symmetry, just find the number of lines of symmetry and take 360 and divide it by that. Unit 3 talked all about all the different ways that triangles are congruent. So you want to remember side, 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 angle, side, angle, side, angle, 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 side, and HL. And these are shown, remember that sides are shown with the mark on the side, whereas your angle is going to be inside your shape with a little semicircle there as well. One where a lot of students get confused on is the difference between ASA and angle, angle, side. So just remember for angle, side, angle, that side has to be between the angles versus angle, angle, side is hanging outside of there. HL only applies to right triangles. Got to have the right angle, the longest side with a mark, and one of the legs with a mark. Furthermore, when you are doing a proof, remember that your first reason is always given. Remember that you want to mark up your shape every time you see congruence on the left side of your proof. And some of the big theorems are going to be your reflexive property. And that's when two triangles touch on the full line. That side is congruent to itself. Your vertical angles is another common proof reason. And that would be shown here. So your triangles, they do touch again. They just touch at a point, in this case, point C. And then if you do have a parallelogram or anything with parallel lines, well, you can go and they marked in your alternate interior angles here for you. Furthermore, if you want to prove that a certain side or angle of a triangle is congruent, once you've shown that they are congruent, CPCTC will show that any given side or angle that corresponds is congruent as well. Unit 4 was all about similarity. So congruence has to be the same size with the sides and the angles. Similarity is a little bit different because the sides could be different, but the angles do remain the same. So it's the same structure in them. They're just different sizes. In this unit, we talked about Pythagorean's theorem, which is your right triangles. You want to make sure you are drawing your arrow over from the box to tell you where side C is at. And remember, last step, you're taking the square root as well. Furthermore, perimeter of your triangle, you just want to add up all of your sides. Your area of a triangle formula is there, 1/2 base times height. And this is the symbol for similar as well, just that little squiggly line, but there is no equals. With that, we set up a lot of proportions for that as well. So just make sure that when you set up your fractions and you do your butterfly method, both parts in your fraction should be coming from the same shape. So x over 7, that was the left side over the bottom side. Well, you set that equal to the left side over the bottom side in your other triangle, so 8 over 14. For problems like these, make sure you're cross multiplying or crisscross method. I've seen it taught both ways. Same thing, but that will let you solve for x. Unit 5 is all about circles. Biggest thing with circles is knowing about the radius and the diameter. So the radius is half of the diameter. So if you do want to find your radius and you have your diameter, just divide it by 2. Your formulas for circumference and area all depend upon the radius as well. We've talked about your inscribed angles, your central angles, and the arc. You got to know that your inscribed angle is the smallest part. So if you are looking for the inscribed angle, you want to be dividing your central angle or your arc by 2. That's the smaller part. If you're looking for your central angle or arc and you have your inscribed angle, you want to double it, which means multiply by 2. Furthermore, if you have an inscribed quadrilateral as well, you want to know that your opposite angles inside of your inscribed quadrilateral, they're going to be supplementary. So those would add up to 180. Furthermore, if you want to find a circumscribed angle, which comes off of the circle like this, you just want to take 180 minus the arc. For your equations of circles, it's important to remember that if you're trying to write the equation of a circle, you need to know where the center is at, and you need to know how big the circle is, which relates to its radius. In your general form of the circle, remember you want to just switch the signs for the x and y coordinate. Like in this example, the center is at 2, -3. So when they write the equation, they're changing the sign. So they put x minus 2 and y plus 3 squared. And then remember, you want to square the radius. So this radius was 3. 3 squared, 3 times 3 does give you 9. With probability as well, the biggest things to remember are you want to know the difference between and or. If you have 2 or more events and you are saying and, make sure you are multiplying those 2 probabilities as well. If one of the events depends on the other, make sure that second time you multiply, you're taking that into account. So you're doing the probability B given A is true. If you are using or, you're being less picky with your probability. So you are adding your 2 probabilities as well. If they do overlap, just make sure you are subtracting off that overlap as well. So if both events can happen at the same time, make sure you subtract that off as well. And then finally, remember that given is shown by this vertical line as well, and your equation is down there. The final things I want to say is make sure you are using your reference guide. I'm going to pull that up and show you the important things you do need to know on your reference guide. Getting started on the front, if you ever need to convert anything between different units, all your conversions are at the top. Your trig stuff is going to be at the bottom of your first page. This will tell you how to do sine, cosine, and tangent. Remember that A here is going to be your angles for these, and then you're matching up the sides. Trig identities on the right. On the back is where you're going to have all your formulas. So for your circle formula, here's circumference and area. Parallelograms and triangles are up here as well. And then on the right side, you have all your other volumes. The thing I want to point out, radius pops up in a lot of those whenever you see R. And if you do see a big B, that means the area of your base, which is length times width, okay? So you can do that for those. You are also provided distance formula and the addition rule for your probabilities as well. So that's all I got for today. Do your best today. Make sure you're answering all the questions. Bookmark the ones you don't know. Come back to those at the end and use your reference sheet. Good luck to everybody. I'm proud of y'all. Make sure you leave your best effort on your test today. Good luck.